Here we go. And we are back with a highly recommended guest from Elliot, actually. So Matt, the pressure is on you to bring the heat today. But I've been seeing more and more, not posts, unfortunately, Elliot. You need to start putting them back on the internet, but photos from Elliot on doing one-story intentional mock-ups, maybe not multi-story, and
We did
focusing
do a
more on the wall.
multi-story for Matt.
So we'll get into that, but focusing more on the wall outside of just the window. And Matt, I know that's where a lot of your time and attention goes. So let's first, before I start asking questions and annoying you, introduce yourself and where you spend a good amount of your time focusing.
Cool. No, I appreciate being here, being on. It's about damn time. Matt Capone, I'm founder of FacadesX. We're about 10, 11 years now in business, and came from the architecture world, went to school for design and thought that was the way to rule the world. But then the dark side came calling, and sort of the need to, instead of focusing on a project, basically solve, individual problems on a lot of projects. And we fell into the facade niche. My time with Shook doing the isocorbs was like my first taste of like bringing something new into the market. So I guess that's kind of our focus. Our products and solutions are things that, are not typically common, but we're trying to advance efficiency. We're trying to make things easier, I guess, in a nutshell, bring value. And so we represent, a dozen strong products, and we're more pushing into now how to take each of those products and put them together and mash them into something that is more useful, and working with Elliot, on the testing of those things. So we're making strides to make the built environment better, and some of it's glass, but yeah, a lot of it is opaque wall, rain screens, high performance, that passive house world. I'm a Boston guy, born and raised. I had a lot of work in New York. I ended up in Connecticut, but a lot of our work is in the Boston market, and Massachusetts now, as you're aware, is like leading the country in efficiency. And when I was working on a passive house 10 years ago, my GC at NASA Construction, where I was working, they were like, passive house, what is this? This is crazy. Like, why would you're trying to add money to these jobs and like all this, and literally the words passive house are now in the building code in Massachusetts, which I kind of can't believe either. And now there's the design world is scrambling to keep up with this stretch code and all these other pieces to add on. So I think we provide a bit of a consultancy along with the products and the solutions, trying to kind of fill a void, which is a good niche. And just following markets in New England and New York City. We're pretty much Northeast. Things are similar but different. As you know, very much a different world in New York. So we kind of balance the two and see what kind of trouble we can get into.
Well, so I know passive house is one of Elliot's favorite buzzwords, and so we see sort of in situ stick built assemblies achieve passive house rating in a commercial construction, and we also see panelized systems achieve it. And here is you sitting offering both of those paths. And so let's get away from panelized for a second, because I talk about it too much, and talk about maybe more cost efficient or cheaper alternate stick built systems, assemblies, materials that you can use. Where do you see that path go wrong?
I see the architects tend to hyper focus on one product in the wall cavity, like as a means to hold the cladding up, girts and clips and things. And so I think it's hard to know what the right solution is at the design stage, who's going to be the installer, what exactly is going to be the layout and the loading on the panels. So we like to see things be more performance based, like, hey, this is that cavity. We need a U value of, X. What is that? It's R. We want R22. Is that a requirement? Is that a goal? So we like to see that more of a performance based, so that individual manufacturers and delegated design engineers and the teams who work on that can solve the equation in the most efficient way. And to me, the other part of it is really, that install cost, time, lapse around the building. And so we've been big in the structural insulated sheathing market, right? So it's like the anti-clip, if you will. So basically products that include, a non-combustible structural sheathing. They include the insulation. Some of them include the waterproofing, but we've seen that really kind of want to be a separate animal, because just different people are good at different things. But getting the best value out of that wall section is actually the key to not only meeting the passive house performance, but also keeping the building dry, durable, and letting Elliot test the hell out of it to make sure it doesn't leak. So,
Hey, Matt, maybe expand on the structural insulated sheathing a little bit because in our market, the market Adrian and I are in mostly, it is almost non-existent and unknown pretty much.
I do agree, right? And so, we see that New England market and then we see the New York market. They're vastly different from us and in frankly how we pitch it because we know change is difficult. In Boston, we're seeing a big shift towards the structural sheathing of a few different varieties, but really
But the
it's kind of the
insulated structure.
insulated version, right? New York is very resistant to that in terms of the change. I feel like in Boston, also after the drawings are done, there's a lot more I would say possibility to shift or adapt and do things on the fly. I think with NYC DOB requirements and filings, that becomes a lot harder for someone to come into a project after a permit set and say, "Oh, I think this is a better way to do it." So most of our early projects using structural insulated sheathing have been, "Hey, I think we have a better way here." The installer gets buy-in, the GC buys in, and then we kind of go. So New York is definitely harder in that. Also now more strict requirements about this uh, 2022 building code requirement for compartmentalization. So there was, some confusion and lacking clarity on how that would be enforced and would that apply to insulated metal panels? Would that apply to EFIS? And would that apply to structural insulated sheathing that wants to really be continuous? So
So
I think that, yeah,
probably when Adrian and I think structural insulated sheathing, we're thinking dense glass. But you're talking something that's completely different than dense glass, right? It's
right.
a
So dense glass is
not a gypsum based product, right?
So dense glass is gypsum based, and it's neither structural nor insulated. It's really just a non-combustible element for you to put waterproofing on. When we're building panels with it on, it's very often that a panel's going to ride with a foot through it because it is basically drywall. So the evolution has been towards an SIS product that's faced and covered by a magnesium oxide board. So mag board is basically the term, and that's a much more robust, kind of like dense glass on steroids. It's completely non-combustible, but it's a lot stronger, and so it's going to hold up on site. And the critical difference is that once that's screwed to the steel framing, to wood framing, to concrete, once that's applied to the building, that's actually the layer that's holding the cladding on the building. So that cladding, the fasteners are not going back to the studs. So now you're free from that grid. You don't have to find the studs. QA process is actually a
Because
lot easier.
that
Yeah,
MGO board can actually support screws directly into it, not through it into a stud.
correct. And there's a lot of data on the actual screw. So there's a specific screw to use. It's a little bit of a wide
mean-
thread. So
You mean they actually calculate their connections?
absolutely. No, that was the biggest thing to get this in. I've gone to many job sites like, "Oh, this stuff's garbage. It doesn't work." We screwed to it. So, there is a prescriptive screw type that's to be used. And that's really like, if you just think about hanging a picture on drywall at home, you can do it. You got to be a little bit careful. So you can't overdrive the screws. You got to use the right screws. But basically, we're seeing products that have individual screw pullout, around 250 pounds of shear and pullout. So really, your facade just becomes a delegated design evaluation of how many screws do I need and what spacing. We've done jobs with fiber cement, terracotta, porcelain, stone veneer. So it's really it's unlimited in what it can do. It's just how many screws you need. So that pullout is very good, actually.
And actually, what you just said about specific screws and not overdriving the screws, that's all the same for gypsum-based sheathing too. You
For
can't
sure.
just put screw whatever kind of screw. You can't use drywall screws on the exterior, whether you're not directly fastening, whether you're fastening through the gypsum board. You can't overdrive. You have to have the special head so that it doesn't pierce the waterproofing layer of
Right.
the air barrier layer of the gypsum. So
Right.
that's just good practice on any kind of sheathing you use right now, whether it's wood-based, gypsum-based, or magnesium oxide-based.
For sure.
Yeah, we've I haven't lately, but gypsum-based sheathing was one of the things that I had a little bit of a hard time with over the years, and kind of wrote lots of articles about, not articles, but posts about the dangers that we saw of, just throwing gypsum-based sheathing up and not following the manufacturer's directions and best practices, because literally you're trying to hold that on with little bugle head screws most of the time, and no one pays attention to load charts, spacing recommendations, things like that. And yeah, we see a lot of failures, especially when there's ephes on it, because everyone thinks that the cementitious part of the eaves is failing because it's not good, and it turns out no, it's not that. It's the substrate that it's getting applied to that's moving beyond what it's supposed to.
Right.
Sorry.
No, that's right on. And actually, when you're doing all these multiple layers in one and creating a composite sheet, while let's say structurally you're not using this, like the EOR is not using this for stiffness in the building, but when you're putting this on 18 gauge framing, you're substantially stiffening that wall, right? And so we now have a product that we have, fiber cement cladding that has an ICC certification, and the maximum, let's say, ultimate PSF is like 67, right? With 18 gauge spacing, 18 gauge studs at a certain spacing. We just did testing with a structural insulated sheathing, and the average was negative 142 PSF. So we're now showing manufacturers that if you use this, you can actually increase your potential and height and access to buildings that, you sort of didn't have before. So how does one product help the other is, I think, a lot of what we do to find that best fit. So,
And how is it with water penetration and air infiltration?
so typically it's going up like regular sheathing. I mean, people have seen different products in the market, like Armor Wall. That's one, for instance, that wants to, we were one of the first Armor Wall guys, and we were really big on that in the New England market. And it was interesting that the push was really to be the all-in-one solution, including the waterproof layer, and applying that to a sheet is no problem, and that works, but it really is about the edges and the penetrations. And so I think that's difficult to control at the framing level, especially when you're shifting the responsibility of who the installers are and what they're doing. And so all of a sudden that guy is like, oh, I'm the waterproofer. Okay, that's fine. I guess that's more cake for me. But in that comes liability and issues with movement. So I think what we've seen, the trend is more that, it's a better system if you're kind of leaving that as a secondary layer, and it comes on after. So that's kind of how we're approaching it now. The mag board is very strong, very durable, very non-combustible for type 1 and type 2 construction, but it will absorb water. Absolutely. It does not like water. So you need a robust air barrier on there that's either liquid or peel and stick. We've mostly been using the peel and stick because that obviously covers the surface, but then allows the gaps and the joints to, be really protected, kind of belt and suspenders. So in the past, when we were relying on that built-in AVB layer, we would see that, there was a creep of, areas that were the edges, had to be rehit and gone over a couple times. And so is that really the most value you can bring? So partly about durability, partly about install, but separating that one piece. And
So
then
treating the waterproofing and air barrier as an actual trade, and not something that we're throwing on laborers, is actually a good idea.
that's how we see it now. Absolutely. Absolutely.
The architects know how to detail this, and when I say that, the standard in mid or high rise construction is to get a set of design development documents and see them, and basically what's drawn is a floating storefront assembly or system within a glazed opening, and you get to the point where your glazing contractor is going to figure out the means of sealing and waterproofing and attaching and engineer it. Is it the same concept with cladding materials? Is it left super vague so that multiple people can bid it, or contractors can approach it how they will?
I think it's a little more specific. It's interesting that like you said, storefront, window wall, and curtain wall is very much a ghosted in idea in architectural drawings, delegated design by XYZ. I feel like in the rain screen world, in the cladding world, there's a tendency to be more proprietary based on what they think the building will have, or what that look is, right? And, I think in that world, that you want fiber cement, you want porcelain, you want terracotta, that, but you might not know the exact manufacturer you're going to be using. There's a spec, you have a basis, there are approved equals, and others that could bring value. And I've heard of a couple jobs being over budget lately. So everybody's trying to find that value. So in that are some different, let's say, ways to solve those window trim conditions and the other details. So I think that just needs to be a little bit open. And also that, one system might be a quarter-inch thicker, a quarter-inch thinner. It's really about that intention. So we like it when the architects leave a lot of intent and design aesthetic, but a little bit of openness on how that sausage is going to get made and the means and methods to get it there.
And how does that world work? Is it facade contractors buying out the material and engineering the installed configuration, or do you have instances where these suppliers are selling directly to general contractors and they're just general contractors are relying on whatever labor force they could find to go in and smear it on and put it in?
We're seeing both. I mean, obviously, I think the New York historical market is furnish and install, we own everything. I've done 45-story buildings where the GC is buying the material and assigning it to the installers. I know a lot of installers that really hate that, but there are installers who like that. They don't have as much liability. Their cost of goods sold is not hitting their insurance in a big way. So that's trending, I think, towards being a little bit more open, but there's still many who would refuse to do that, or would refuse to take a contract where they're not buying the material in case they run short or something goes wrong. In the rain screen world, especially in multifamily podium construction, there's a tendency, to be very cost effective. So what can that be? So there are developers and general contractors who will, they have architects and GC guys on staff that, have come over to help this. So some of them are well equipped to handle a buyout or handle a material purchase and monitor and control that. And so you can get installers to do packages like that. But a lot of larger installers really want to control their own destiny and have that complete furnish and install with the delegated design. Typically, a delegated design is gonna force a furnish and install, but we've also seen it be still separate. And even in New York City, like I mentioned, we've done very large hotel. The GC hired, the engineer to do all of the shop drawings, bought all the subframing, and bought all the panels, and installers put them up. So I've seen it go really well, honestly, and I've seen it where it, doesn't go great.
What is typically the first point of failure? And if you're looking at systems that were installed in the 90s or 2000s that are coming on 25, 30 years old, especially looking at not necessarily the reclad market, but sort of the restore in place market, where's the first opportunity to either move the needle the most, or is everything in essence really at this point sort of a band-aid fix?
I think there are more thinner, lightweight types things. We're seeing a lot of, we're seeing a lot of the New York City white brick kind of co-op buildings, right? The tendency was, okay, what can we put over the brick? That's a good way to go if you can. We've done several of these, reclads where that brick veneer is taken down and all you're left with is 4 inches of block, plaster, and tenants, grumpy tenants, so there's that balance between the two. And, it would be nice if you can keep the brick like let's say for the disruption purpose, but on a lot of projects, it's not feasible to keep that in place, or you don't have the room, the depth, or, just structurally, it's not sound and how you connect back. So we're seeing a lot of different things happen here. And now there's some green zoning that gives you some bonuses on FAR if you're doing retrofits. So you're allowed to keep it out. But there's this balance, we've done in the Boston market, we've done several projects where they take the brick down and at the end they're like, such a cost to dispose. What are you opening up? What are you finding back there? And so what we're seeing now is that folks would love to keep things in place if at all possible and go on top. And then what is the delivery method of that? You know, is it a full structural sort of exo wall outside, or is it really just adhering some cladding? You know, typically that's going to depend on how you can attach to the slabs. In most cases, we're finding that the sort of brick cavity block is a no-go zone for attachment. Literally, we're at 0 for structural. Let's say worse than 0 because they say, oh, you need to go to the slab edges, but also, you know, you need to help keep this in place. And so if you're running slab to slab, you're also going to have tiebacks at thirds
Stabilize the brick
to stabilize what's behind. So you're almost pulling double duty. And then also that wherever you have those verticals that meet the window jambs, you're going to pin the windows in that new structure. So that's very typical.
Elliot, you know where I live now, and it's a lot of new construction building in that area, but walk 5 minutes closer to downtown and you have just all these older, brick clad, horizontal slider, high-rise 30, 40-story buildings. And what is the real, once you get out of, call it the Manhattan area or the New York City area, what is the real motive or incentive to upgrade these buildings? And some of the suppliers that you're seeing that are looking to overclad a lot of these affordable housing developments, do you see more of that? Do you think it's going to start to pencil on paper, or on the contrary, are you going to see more of what we previously spoke about, where you're basically seeing replacement in kind, pour into bridge aluminum windows getting replaced with pour into bridge aluminum windows and just a new insulated glass unit? The question is there any sensibility or intentionality behind these decisions, or is it we're going to do the best we can?
So I think my answer is going to tie into the question that I was about to ask Matt, is how many architects and engineers are you working with that can handle a job like you just described? Getting back to the structural elements, whether it's a slab or a spandrel beam, stabilizing the existing wall, in doing proper energy upgrades, not just waterproofing and aesthetic upgrades. We're finding that, you know, there isn't enough real knowledge base, and there isn't a resource for people to go back to and look at good case studies that were examined, explained, looking at the good parts, looking at the bad parts. Some of these skin rip-offs and overcladding or recladdings are 8, 9, 10 years old now. It's important to start looking at them more than just anecdotally, where people say, oh, the difference in acoustics, the sound in my apartment is so much better now, and the we're so much more comfortable because the heating and cooling works so much better, and we have the aesthetic upgrade. What I see happening right now in New York and other cities is, after COVID, with the non-use of office space, obviously this office to residential conversion craze that's hitting just about every city right now, is people rushing to do whatever they can do to make those buildings work for residential. And some just don't, just because of the way they were built, right? But some can. And you mentioned removing the old window and replacing it almost in kind with upgraded glass and maybe a better frame. And we're looking at this, and we do some unique energy measurement and testing where we can tell you exactly what your old windows are doing and help you model the new windows to maximize the efficiency of your facade, not just the windows, but the windows in the wall. And the truth is, almost never does a replacement of a window pay itself back on energy savings. Not never, but almost never will it happen. And it's got to be really bad, leaking lots of air, single glazed, old, non-thermally broken frames. Then maybe you have a reasonable period within 12 to 15 years of paying back the cost of a new high performance window. So what we try to stress to people doing these office to resi conversions, or looking to just get rid of the old facade that they have, is now's the only time when spending some extra money on high performance insulation, high performance glazed units, whether it's curtain wall, windows, whatever it is. Now's the only time that the differential cost makes sense, because if you're doing the upgrade just to save energy and think that that's ever going to pay itself back. It almost never happens. So
Well, what about the office to residential? There's a real motive. We have an underutilized asset and we want to try to attract tenants for a new use. But what about the residential to residential conversion? So remember that I don't remember the building or the company that worked on it, but there was some case study in the East 70s. It was a white brick building. And remember some firm came
79th
in,
Street. It was a
they
Rudy
did a
job.
whole, this
Yup.
is going to
We
be our
worked on that
local law.
project.
Yup.
Yeah, that's
This is going to be our
201.
97 case study, local law 97 case study, and we're going to rip the brick off and put on beautiful insulated cladding and new windows, and this is going to be the model for what we can repeat. What you
I'll-
just said, is there
I'll
not?
get Ralph Forst on for one with the three of us. He was the facade consultant on that one.
Yeah, no, it's important. The question becomes what you just described, that level of effort and sophistication from the planning and design team. Is there just not enough of that out there to have that type of impact on the project? And also, it's a huge investment from the building owner to make that decision.
Right. So
and-
this, like 79th Street, for instance, like that job we were, very involved in. So it was like, co-op, first of all. So however many units is how many owners, right? So getting a consensus is difficult. But, what is your facade maintenance program like every year? And what does that cost? Who wants the sidewalk shed up there for 3, 4, 5 years? So definitely was an efficiency, definitely a safety. But also, we know that these older buildings are competing for presence on the corner, right? So a lot of these co-ops and older post-war buildings are competing for marketability against newer buildings with higher floors and a more, let's say, swanky facade and more elegance. And so even in residential to residential, they're looking to reposition and get more value out of that. Co-op, again, is hard. And even on a project like that, like Elliot said, like, here's your chance to replace the windows. And it was interesting that if you did not want your windows replaced, you did not have to. That was an individual unit owner decision. You couldn't force them. So it's interesting. The only place you could force them, that building was from like 1952 or something. The only place you could force them is if they were literally the original windows. But if you had ever upgraded your windows, like in the 80s, they could not force you to take them out. So I know that the
code
installer,
compliance.
yeah, the installer, when doing sort of the window surrounds, we know that they had to, we were joking that, okay, you need to leave removal instructions next to inside each window jamb about how you're going to do that. Here you're spending millions on a new high performance facade, yet leaving some pieces out. But I guess that's part of the requirements. And we've looked at many others that are apartment style, right? So single owner, rental, obviously that's easier to control your destiny and, let's say, manage the tenants and, a move out for a day or two while that's being replaced. So a lot of different concerns.
Is the answer that, just like we know a certain company that's trying to deploy a rinse and repeat model of doing this type of upgrade on a certain type of building, is the answer to, we need a repeatable process that people can use so they don't need to lean so heavily on Ralph Forst or somebody else to implement this?
I think you need a repeatable process, but you also need some flexibility on the end outcome and the design and what it looks like, right? And so does every building want to have that sort of unitized black framed, perimeter and, let's say, panelization effect, so flexibility, I think, is important in the aesthetic.
So that was what we refer to as a stick-built project, right? Everything was done individually, removals, structural attachments, new facade, waterproofing, everything was done individually. And, the big promise, and you're the second person to ask me about that, can we just get something that doesn't need too much involvement for professionals? I don't think the engineer and the architect were the big cost on this, right? Logistics far outweigh mass climbers on every elevation, sidewalk protection, staging areas, millions and millions of dollars in
Right, but didn't you say
cost.
it's the lack of expertise or repeatable?
Oh yeah,
that's the issue?
definitely. But I think the answer is to get people better resources and expertise, rather than just saying there's a one size fits most solution that works everywhere, because we're seeing that it doesn't. And when you try to remove actual experts from the process, and that's what I get afraid of, not that it's going to limit the experts, but remove the experts, because that's the goal, right? Let's get something where we can just order X number of these things on Amazon and have them installed the next day. It's dangerous because what we see is so much of this. So the panels can go up and clad over the walls, and I'm sure the issues that we're seeing now with how they're being anchored and things like that can get resolved. But every job's different. And you know where they fail? At the bottom and the top, because it's so critical that that space between the new panel and the old wall actually gets airtight, not vacuum airtight enough with the proper amount of insulation so that you get the full effect of this overcladding panel that has insulation built into it, but the insulation won't do anything if air's getting in behind that framing. And that's where we see the issues right now is people aren't paying enough attention to that part. So can we improve it? Of course. With the panelization work, we can definitely improve it. It doesn't mean that they don't need experts involvement, both in design and during construction. Honestly, it's not really a single trade job. It's really not. You still need a general contractor. Believe me when I tell you, everyone thinks this overcladding with panels, like the ones we've been following on LinkedIn all the time, it's just they're going to bring in a single trade guy. He's going to take care of the engineering. They're going to be delegated design engineer of record. It's, believe me, between logistics and all the other stuff that has to be done that they're not including, that nobody's paying attention to. How do we seal it to the ground level? How do we seal it to the roof? It still requires a CM or GC involved to make
Right.
sure that when you're done, you get a complete watertight, airtight, efficient system.
So do you have any I was watching your clip last night with Abby because we were trying to develop a clip, the original one with the air balloons,
Oh
that
yeah.
you used to do in lunch and learns, because I think that's
Yep.
super effective to be able to explain what is a CFM and what does it mean to be losing CFM of air, 50 CFM of air loss, per minute, or air exfiltration, and have to either reheat or recool that interior space. Do you have any equivalents on, or equivalent analogies on the structural side to explain how you can actually assess or validate the integrity of either these window openings or existing walls, and what that would mean to hang a new system on that structure?
So CFM means cubic feet per minute. So a cubic foot, the reason why I use the balloons is a decent sized party balloon is about 1 cubic foot of air. And I used to say, imagine every minute, 50 of those entering in, that's 50 cubic feet per minute. So PSF is pounds per square foot. So you have to look at your window as being 30 square feet, your wall being a section of a wall being 100 square feet, and say 40 pounds per square foot equates to this many pounds against that thing. Now, how are you anchoring? Are you putting a receptor system in and just, you know, really evaluating it at the head and the sill to do the total support of the window? How are you transferring that load that the wind pushing against or pulling against the building transfers to that facade? How are you anchoring it? And what's acceptable and what's has proper safety factor built into it? Can you screw something into a face brick? Sure. You want to put a piece of conduit to run some cable wire up the side of the building? By all means, you're fine screwing it to face brick. Do you want to hang a 900-pound panel off of it? That's where there's so many things involved where that's not generally acceptable in our industry to do that, because even if it calcs out on paper that you put 30 screws in every 10 feet, that brick is not a solid, stable element of the building. Concrete, we know how that reacts and how it reacts after it gets old, or how it will perform after it ages. We also know how brick performs after it ages, and it starts to get cracks and it starts to spall, and it has weather related aging elements that don't make it an acceptable surface to anchor to. And, in Europe, buildings aren't tall. There's the wind loads in most places in Europe are so much lower than they are here.
Right.
So they look at dead load as the primary factor. We don't. 10-pound per square foot panel, 12-pound per square foot panel is a quarter of what the wind load is on a average building in New York, Chicago, Philadelphia, LA. Our wind loads are higher here. It's just the nature of our geography and the nature of how we have accepted safety factors in the United States. Our building code may be a little more stringent when it comes to wind loads. European codes might be more stringent when it comes to energy, but there's a reason why we in the United States, our first concern is usually fire. How do we stop fire from spreading throughout a building or from one building to the next? The next thing is structural, right? Is this thing going to stand up? And, that's why we have to look at that PSF, pounds per square foot. That drives everything else. Ratings of windows are based on design pressure, which is based on how many PSF of wind load. Water resistance performance of a window is a fraction of the wind load on the window. So that's the way I would look at it. Just do the square foot, length times width, and then say pounds per square foot, and then it'll start to give you more of an understandable metric of what that means. I think too many people don't know what CFM, PSF mean, and that's why it's delegated to someone else.
It's
Sorry.
interesting where we see like these
Good
reclad projects, they're connecting to, an old facade, and it's like, well, we did a pull test. Okay, and it passed, and you're testing the ability of a hole or a bolt to stay in a hole. But what we're most
At
concerned
one
about
location or 10
at one location,
locations.
right?
Well, that's the thing, and that's what you also, the other point you brought up, are you testing in the configuration of the load path of the new, not the existing facade, but how the new facade's going to be installed and act in time?
So you can. I mean, we have pretty good engineering software today that can simulate lots of things if you enter them correctly and ask the correct questions. But you can. The question is, do you feel confident in what you're anchoring to over the lifespan of what you're putting on it? And for me, brick just doesn't do it. It just, there's a reason why we have local law 11. It's because brick facades needed to be inspected, because as they weather and as they are exposed to temperature shifts, things happen to brick. Brick is an awesome material. I love it. I think I posted 500 pictures of that mock-up we just did with Setra Ruddy, where the brick is literally, the pictures don't do it justice. I love it, but it has to be used it can be used as a structural element when it's used correctly. I'm not a big fan of hanging things off of it that have to resist wind load, dead load, thermal changes. I think it's just not. I don't care if you use epoxy, whatever you're doing. Like as I said, it works on paper, but the guys with the gray hair know that it's not going to work forever, and we need to build facades that will last, at least safety-wise, forever.
So is that 79th Street job at least, I'm guessing it's somewhat nearly fully occupied now and it's up and running?
Yeah, that job's
Yeah,
fully complete. Yeah.
yeah. It was occupied during construction even.
Yep.
We should let's schedule Ralph Force and talk through that project and lessons learned, and I don't know, it was all over the place when it was happening, and I haven't heard a thing about it since, so I feel like that's perfect.
It's got to have been 10 years, right, Matt?
No, I must be thinking of a different example. I thought Elliot in 2022, 2023, we were talking about that as a, perfect local law 97 candidate.
Yeah, Ralph has done several of these. I believe the one on 79th Street it is a newer one that was not with Ralph Forst. So
Maybe there's one that they were utilizing a mechanical consultant, Elliot, and they were looking at sort of
Oh, is that the one with Eniad and Matt? Maybe you remember.
it might be they were looking at what is the metric that, I don't know, what is the metric that local law 97 was measuring to basically qualify your carbon footprint or your carbon output on a what square footage basis, to see if you were under or over the threshold. They were trying to measure the energy performance pre-reclad or retrofit or renovation and then post. And I haven't heard anything about how the project's gone post. That's why I want to look into that and see how some of these projects have done. There was so much talk about it in the design and planning, and then execution happens, and everybody's focused on something else.
So
Yeah.
you were joking about me and Passive House when we started, and it's not just Passive House. I'm 100% behind the concept of Passive House, but
Your second favorite is Lead, right?
Lead, all of them really. Listen, I have a real problem that I can't easily go on the Google machine and look for a reasonable number of typical buildings post renovation that, or even new construction post occupancy, that show, and I don't mean 3, I mean 50 of each type of building. At all this time, Lead's been around a long time, and so has Passive House by this point. I want to see substantial amounts of data showing how this thing is actually performed afterwards. I know it does. We all know it does, because if somebody's standing there making sure that everything is done correctly, and I'm that guy, I believe in that. We don't do that we don't do inspections, but I push everyone to do them all the time. As a matter of fact, I have a call later today with the DOB Energy Code Revision Committee that I get teased about, commissioning. And I'm like, yes, it's a good thing. We don't do it, but we really want it done, because I show up and do one test. Someone needs to watch every joint, every lap seal, every piece of insulation. That's when we're building real passive house buildings. Houses are different. It's smaller scale. You
could do
know,
the blower door test for the entire house and probably plug
Right.
and identify issues, but 16 stories up, you're screwed.
So we can, and we're trying to figure out better ways to do the larger buildings. And I think we have really good stuff that we'll be doing in the next year or two. But logistics of a high-rise, mid-rise building don't always allow you to do the testing that you need to do, which is why we say do the mock-up, look for issues on the mock-up, get us in there early, try to do as much as you can early on so we can identify issues that the commissioning agent, that the special inspector can then go and monitor as they go. Us doing a test and saying, hey, you have this problem, and then it gets filed in a folder is not the point of us doing a test. We're not checking a box. We're giving you something to pay attention to as you go,
Right.
and make sure that whether it's a manufacturing problem, an installation problem, a design problem, it gets monitored and effectively changed. Sorry. I know that was a
But,
longer rant.
so let's wrap this up. Let's find out what that project was. Let's confirm if it actually was 79th Street, and maybe regardless, let's continue this conversation with Ralph Force next time. Sorry, Ralph, for mentioning you about 7 times and electing you to do this, but I hope you'll be part of it. But thank you both for coming on. It was
Thanks,
fun.
Adrian, and thanks, Matt. This was great. And yes,
Awesome.
we got to do it again.
Okay. Appreciate it. Take care, guys.
Talk soon,
Thanks, guys.